It started in my own local community. There was a threat to our community in the Santa Cruz Mountains. It's the largest stand of old-growth redwood trees remaining in Santa Clara County. And one day back in 2005, about 2,000 of my neighbors and I got a letter in the mail telling us there was a plan to harvest timber. And there was a sketchy black and white map and a very poorly described plan, and no one really could understand it. But this new thing at that time, Google Earth, had just come out. And I thought, I wonder if we could get a better understanding if I studied the plan and remapped the proposal in the full 3D satellite imagery of Google Earth. And so that's what I did. And it was shocking how much more you could understand what was at stake, what the issues were with the plan, when I did that in Google Earth. And we ended up ultimately using it to inform policymakers, the media, local community, and even the regulatory agency responsible for making the decision. And we used Google Earth essentially to prove the proposal was not only a bad idea for a number of reasons, but to literally prove that the plan was illegal, and we stopped it. And now that land, it's more than 1,000 acres, is being proposed to be permanently protected as public open space. So there's a happy ending.
So what do you think made the difference? What's the difference if you use the 3D imagery?
You can see in seconds, you can grasp in seconds complex issues. For example, the steepness of the land they were proposing to log, how close the logging was going to be. The helicopters were going to be hauling logs over the nursery school and the elementary school. The logging was going to be 100 meters away. None of this was at all clear from the written black and white plan, but when you could see it in this incredibly accurate, detailed representation of the real world, suddenly all these issues were very obvious, and it changed the whole discussion. It also was energizing and motivating to the community, and it encouraged people to get organized. Yeah, what's great is that was seen, again, this is back in 2005. Google Earth had literally just come out, like 2 months earlier. People were using it to plan their vacations and, look in their neighbor's backyard from space and have just fun recreational experiences. The Google execs at that time hadn't really thought that it could be a tool for sort of meaningful environmental understanding and action. So this was one of the first applications of that. And at the same time, Hurricane Katrina hit New Orleans. And the U.S. government was collecting aerial imagery of where levees had burst, which areas were flooded, where people were stranded on rooftops. And the government didn't have a way to publish that imagery in a way that the first responders could use it. And they approached us and said, you have this new Google Earth thing. Could you publish this imagery as we're collecting it every hour? And so the emergency responders could use it. And we said yes. So the team worked around the clock. And ultimately, we got a message from the U.S. Air Force that they had saved the lives of more than 4,000 people using this fresh imagery published in Google Earth. And so that was the beginning of a realization that a tool like this, which sort of puts in everyone's hands this most accurate digital representation of the planet, could be used for humanitarian, for environmental, for human rights, for many, many applications. And I was now at Google and sort of as my 20% project, because every engineer can spend one day a week doing something you're passionate about, I asked permission, could I be the Google Earth liaison to the nonprofit community to help them understand how to use these tools, because they're all writing to me after they heard about the victory of saving the redwoods using Google Earth. One of the newspapers had said, environmentalists used to sit in trees, now they sit in front of Google Earth. So we started a program, we called it Google Earth Outreach, and the idea was to give advice and tools and support to thousands of NGOs around the world and help them understand how they could use these mapping tools for public benefit. There's been incredible applications. For example, Halo Trust is one of the longest operating organizations to remove unexploded landmines around the world. After war is over, you'd be amazed. Millions of unexploded ordnance are left in the ground. It's extremely unsafe for the local communities. Kids cannot walk to school without fear of their legs being blown off. And so the land sits untouched. Halo Trust uses Google Earth operationally to interview the community, show us where you think there are problems, to plan the operations, to actually do the landmine removal. And using Google Earth, they've now removed millions of landmines, and they've declared 4 countries now landmine free. That kind of thing is really exciting for us. There are indigenous communities that are using Google Earth to create a bridge between elders and the youth. The elders have all this knowledge about sacred sites, where traditional practices are taking place, and they haven't had a good way to pass it down to the youth. But they show Google Earth, and there's a connection. They can map their mental model to what they see, and they start, sharing this information, and it gets documented. These indigenous communities, some of them are almost like internet illiterate, but they're able to use this tool for documenting their use of the land and in negotiations with extraction companies that want to do logging or mining. And it empowers them to have, to be able to have a more meaningful discussion and in some cases literally defend their land from invasion. Anyway, I could go on. There's many applications across, all of. Yep, maps are extremely powerful. I think that's the thing to understand. There's absolutely been a change. I think that first phase of Google Earth, it was the phase of seeing is believing, was a phase of how can we use this as a digital canvas to raise awareness and empower kind of a richer kind of communication than you get with slides and, spreadsheets and so on. But that wasn't enough. Then in 2009, I was in the Amazon working with indigenous communities, and scientists came to me and they said, look, we love Google Maps and Google Earth, but it's not enough. You're just letting us look at the imagery. And the problem we're facing is we're losing 1 million acres of the Amazon every year to deforestation. Much of it's illegal, happening in remote parts of the forest where there's not law enforcement on the ground, but there's daily satellite imagery coming in. And if we could analyze that in near real time, we could create like a virtual alerting system that would help us defend the Amazon. And they said, you have all this imagery, but you're just letting us look at this. Please let us analyze it and map and measure and monitor like a changing planet. And I thought, well, that sounds pretty Google scale. Because at that time, and this is still the case, tropical deforestation accounts for a meaningful amount of greenhouse gas emission. And in some ways, the low-hanging fruit of addressing climate change would be to stop cutting down the forest and actually to do reforestation. But there was no good data that was fresh and accurate and global about the state of the world's forests. There was just, ignorance about that. So that led us to build what we call Google Earth Engine. So Google Earth Engine is an analytical engine for petabytes. What's a petabyte? Billions of megabytes of data that's being collected hourly. It could be satellite imagery, aerial imagery, weather data, all kinds of information about the planet that often government satellites collect, and they go onto tapes and they're not very accessible. So how can we unlock those pixels and bring them into the Google Cloud and co-locate the data with thousands of computers for processing it, so you could turn those pixels into knowledge, into insights, into answers to questions that would drive solutions. And that's what we built with Earth Engine. And most recently, we've been integrating it even with AI, so that you can bring both traditional data science and analysis to those pixels, but you can also now use deep learning to discover patterns and classify information, discover features that were not possible with traditional sort of geoscience methods. Oh, absolutely. There's a revolution in data science, and colleges are offering, degrees in this. And we see the field of, it's called sort of GIS or remote sensing, this analyzing of Earth observation data is evolving to adopt methods like AI. There's certain questions that are, were hard to answer before AI came along, and I can give you some examples. But yes, the NGOs are absolutely trying to hire those kinds of people, and we are working with scientists to train them in how to do this, And often what happens is the scientists will advance the frontier of what's possible. They'll publish a paper, and that used to be the end of it. There'd be a paper in Nature or a paper in Science. But now, because the methodology is in the cloud and all the data is in the cloud and it's collected and we manage all of that, the scientists can say, okay, this works now. Companies can use it, government can use it, for example, to do things like precision epidemiology. So, for example, you can use this technology and data to predict weeks in advance where there is likely to be an outbreak of malaria and which villages are most at risk. Because, mosquitoes don't hatch at random. You can predict where they're going to hatch based on temperature and rainfall and the greening of the landscape that you can see from the daily satellite imagery, and you can build a model, whether with classical physics-based analysis or AI, to tell you, okay, in 6 weeks there's going to be mosquito hatches here, here, and here are the villages nearby. It's called sort of spatial decision support. Which villages have had bed nets, which villages have had spraying, which have not. You create that intersection of the risk to the vulnerability, and you can say, and again, they're calling this precision epidemiology. You can say, okay, these are the 3 villages where you need to go in the next few weeks and actually support them with bed nets or spraying. Precision agriculture is going to be increasingly important as the population of the world grows to 10 billion. How are we going to feed everyone without destroying all the forests of the world to convert it to cropland? We have to farm more efficiently. And this type of big data and AI are now being used to be more efficient with what fertilizer, what planting techniques, what irrigation techniques, right? So that we can produce much more, crops per hectare. Well, I'll tell you one area that we're investing a lot in, and that is helping cities. So when you look at climate change and carbon emissions, cities are responsible for approximately 70% of the carbon emissions. More than 10,000 mayors around the world, 10,000 cities have taken a pledge of climate action. They want to reduce emissions due to transportation, due to their buildings. They're looking for opportunities to go solar, improve rooftop solar. They're concerned about air quality. They want to take action. They don't have the data. They don't even know the baseline of their emissions, for example, or the baseline opportunity to go solar. What we've done, and I'm really excited about this project, we call it Environmental Insights. We've taken Google's data, which is, again, the most sort of detailed digital 3D representation of the physical world. And we are modeling things like, what is the rooftop solar potential for hundreds of millions of buildings around the world? And then give that information to the cities. We're also looking at transportation. We can estimate the carbon emissions of all the transportation in every city and give that information to the city. And we're doing this for free. And armed with that, cities now understand the potential for change. For example, the city of San Jose, we gave them, through our Environmental Insights Project Sunroof, the understanding that over 200,000 rooftops, they could generate 3.4 gigawatts of rooftop solar. And that gave them the ambition to say, okay, we want to be the first gigawatt solar rooftop city in the world. And they're creating policies and action around that. We have instrumented Google Street View cars with air quality sensors. We are driving every street in certain parts of the US and actually in Europe. In fact, we're driving in Amsterdam right now. We drove in Copenhagen and in London, every street, and we measured the air quality, hyperlocal air quality. And that's very important because the air quality can vary by an order of magnitude from one end of the block to the other. And when you have mayors, you have cities that want to create, for example, clean, healthy parts of the cities where they want to disallow fossil fuel vehicles, for example. They don't know where to do it. But this type of hyperlocal detailed air quality data gives them the information to make that planning And then once they take action and we redrive, they can know what impact that they've had. And air pollution, as you may know, is kind of a leading indicator for carbon emissions. So there's a lot of this is based on geospatial data, but in the case of this air quality project, we're using, or rather in the case of the solar project, we're using AI as well, because some of the cities said to us, okay, it's good to know the rooftops that are capable of solar and what amount of solar they would generate, but some of them already have solar panels. So we need to know which ones already have it, so what's the difference? And that's where we used AI to study the images of all these rooftops and detect where there already were solar arrays, so they could be ruled out. Maybe this is too much information, but we needed AI because solar arrays look pretty similar to, for example, skylights, and it can be confusing to detect them. But it turned out AI was very, very good at discriminating where there were solar panels and where there were not. So we're looking forward to we've published the air quality data for Copenhagen on the Environmental Insight site. For London, it's there, and for Amsterdam, we hope it will be coming out later this year. To drive, again, the goal here is to help create more livable cities over the short term, and then to help cities address climate change over the long term. So I think where it's going, I think you asked where it's going. I think we're just at the beginning of the application of AI to this big data from space, right? This is sort of the biggest data there is, right? These petabytes of imagery and other data sets, weather and so on. And for us to make the right decisions about the planet, where should we farm, where should dams be built, where should forest be protected versus harvested, decision makers need better information. And the public and media and academia, they need access to this data as well. We need transparency on the way these decisions are made. One other example is Global Fishing Watch. 20% of the seafood that we eat is either illegally caught or unregulated or unreported. And that's because there has been no ability to monitor where fishing is happening, for example, in the high seas, or even close to shore. With Global Fishing Watch, we are bringing in trillions of data points from ships that are beaming their position for maritime safety. And we're able to turn that into a very detailed picture of where, when, and even how fishing is happening. You can tell by the pattern of the fishing boats, is it trawling, is it purseining, is it longlining? And this is important because it's a very good example of right now, because certain parts of the planet are being overfished, fisheries are collapsing, and if we just backed off a little bit and fished more sustainably and set aside certain areas for no fishing, the oceans could be abundant for generations to come. And this can be driven by data, right, to inform everyone. And that's what we're doing with Global Fishing Watch, and it's now been adopted by Indonesia, by Peru. It's being used in a number of countries, and it's fisheries where it's being used are actually recovering, right? So I think what the big picture here, I think, is the power of not just the raw data, but with the analytics and with AI, the ability to distill all of that massive amount of raw data into extremely actionable insights and answers that the decision makers who are very busy need in order to make better decisions. And this is cutting across whether it's like forestries or fisheries or water use or, how urban development should happen, agriculture, like all of these are now being informed. And I do believe we're just at the beginning of the power of this, big data from space together with AI to give those much better, answers so that we live more sustainably.
Thank you.
You're welcome. My pleasure.